I'm here with three of my colleagues, Frederick Ruhr, Adam Gibson, and Yorgos Choudalakis, who are all working on one particular analysis called a DiJet exotic surge. So you're looking at two jets, DiJet events. What exactly are jets?
We have proton collisions. The most common thing that happens is we have two jets that are produced. So this can be a quark or a gluon that is produced, but we don't observe this. So we see a spray of particles instead. It's this spray of particles that interacts in the detector. In our software, we reconstruct this and we call it a jet.
What can you tell by looking at these showers of particles?
The first thing you can tell is how much energy and momentum each shower carries. And the second thing, when you look at the whole event, is how far apart are these two jets from each other.
How do you see this trace that you had a particle that was created?
So in the standard model, this is sort of a smooth distribution. So what do we look for? Just bumps. If we have a heavy particle, then at some particular mass, maybe at 2,000 times the mass of the proton, we might produce some excess. So we have some smooth background, and then maybe a bump on top of this.
And you look at the angles, though, too. What do you learn from the angular distribution?
If you don't have enough energy to produce directly the particle that would decay to the two jets, there is still a chance of observing it through the distortion it will cause in the angular distribution of the two jets.
So this sounds like something that Rutherford did.
So Rutherford took alpha particles and fired them into a gold foil. Instead, we fire protons into each other. So from the standard model, if we take protons, most of the time we have soft, small angle scatters. So protons come in, we get jets out that are at some small angle like this. If we have some new heavy object instead, we can have much larger scattering angles. So two protons in, and we see two jets in the central portion of the detector. So we look for an excess of those kind of central events.
We are pushing our explored territory farther than it had been before. We exclude things that could have been there, could have been seen, but were not seen this time.
To explain the multitude of objects we see at a deeper and simpler level, and to reduce the complexity that we see in our world to a more fundamental level. If there is another layer, if there's more substructure to be seen, and if we can get things to an even simpler theory.
We came from an atom to a proton, and now we're about, again, that far. So we look inside quarks, and we see about 5 orders of magnitude further, and nothing so far.
And the quark is the final component, the smallest we can get to?
So far, that is what we can say, but that is not the definitive answer.
What are all the other things that you could find?
A common example is the Higgs, but this is not the only thing that could be out there.
So another possibility is new forces, or familiar forces like gravity, that may become strong. And we hope for surprises as well.
The result is exciting because we managed to move into unexplored territory, and really we are in uncharted land now. We haven't found anything yet, but we would like to continue with the new data coming in 2011 to look for new physics and go beyond the current boundary.
Will there be a lot more data in 2011?
So yeah, this year it could be 100 times as much data.